Okay, so today in chemistry, we are going to consider look at the topic called bonding. And under bonding, we basically look at the types of bonding. So the types of bonding, basically, there are three types of bonding that we consider. There are three types of bonding that we basically consider. So when we talk about a bond, we are simply talking about a link or a force that keeps two particles of matter together. Okay, so it is a force that holds atoms together in a compound. So we'll start with the first type of bond that we have. So the first type of bond is what we call the ionic bonding. Now, what is an ionic bonding? So an ionic bonding, it simply means an electrostatic attraction. So an electrostatic attraction between two atoms where one atom transfers an electron to the other atoms. So in simpler terms, ionic bonding, it is a strong chemical bond formed by the electrostatic attraction between oppositely charged ions, which arise from the complete transfer of one or more valence electrons from a metal atom to a non-metal atom, creating a positive ion or cation and a negative ion or anion. So in simpler terms, we can say the ionic bond, it occurs between a metal and a non-metal. For example, we have sodium and chlorine. So now, when you look at sodium and chlorine, sodium, it is a metal, and chlorine, it's a non-metal. Okay, so the type of bond that occurs between a metal and a non-metal is what we call the ionic bonding. So how does each element bond to, how does these, or how do these elements get bonded together? Remember, this type of bonding called ionic bond, it is the transferring. Okay, it is the transferring. So by nature, remember, you're talking about a metal and a non-metal. By nature, we know that metals, they lose electrons for them to be stable. That is the nature of all the metals. And by nature, non-metals, they gain electrons for them to be stable. So in chemistry, losing, we use a positive, and gaining, we use a negative in chemistry. Okay, so now let's look at the electronic configuration for sodium and see how many electrons is this sodium expected to lose. So sodium, it is written like this. So this is sodium, and we have 11 atomic number and 23 mass number. So the electronic configuration for sodium, we have 2 to the ratio 8 to the ratio 1. Then for chlorine, the atomic number is 17. So that means we are interested in the atomic numbers, by the way, and not the mass numbers. So writing the electronic configuration for chlorine will be 2 to the ratio 8 to the ratio 7. So that is 10 plus 7, that is 17. So now look at this. Since the type of bonding here for sodium plus chlorine, it is going to give us sodium chloride. So sodium plus chlorine is going to give us sodium product, chloride I mean. So sodium and chlorine, these are reactants, and these are products. Okay, so look at this. Ionic bonding, since it is the transferring of electrons, how many electrons are going to be transferred from this sodium for it to be stable? Remember, the purpose of these electrons to lose or gain electrons is to have a stable compound or stable atom. When you look at the number of electrons that we have in the outermost shell here, we have 1. That means sodium is going to lose 1 electron for it to be stable. Now, when you look at the number of electrons in the outermost shell here for chlorine, chlorine is going to gain 1 electron for it to be stable. That means it's going to have 7 plus 1, that is going to give 8, the complete number of electrons in the outermost shell. So we are going to draw the electronic structure now to show the bonding of sodium and chlorine. So we are going to draw the bonding to show sodium and sodium and chlorine. So we are going to start with sodium. So sodium, the first shell for sodium should have 2 electrons. So the first shell should have 2 electrons. So those are 2 electrons. Then we have another shell. So the second shell is going to have now 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So 7, 8 electrons. Then we are going to draw another last shell. That is going to give us 1 electron. So when you count the electrons that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then this sodium is reacting with chlorine. So for chlorine, you are going to do the same. So the first shell with 2 electrons, then another shell. So another shell, how many electrons? So 8 electrons. So 2, 3, 4, 5, 6, 7, 8. And we are going to draw another shell for chlorine. Okay, so that's another shell for chlorine. And how many electrons? 1, 2, 3, 4, 5, 6, 7. So these are electrons now that we have for sodium and chlorine. So when these two react, what we are getting is sodium chloride. So now this sodium is going to be a sodium that is going to lose 1 electron for it to be stable. So this sodium is going to be a stable sodium. So that means the number of shells will be reduced for sodium, because the one for 1 electron is going to be removed. So we have sodium here. Okay, so since it is 1 electron, for it to be stable, we are going to put a positive here, indicating that it's going to lose one electron. We are also going to have the one for chlorine now here, and for chlorine the number of shells will be maintained because it is only one electron that is that chlorine is going to gain for it to be stable. Okay, so we are going to write the negative here. Okay, so we have chlorine here. Okay, so we have, let me just write it properly. Okay, so that it is more clear. Okay, so that it is more clear, let me just write it properly here so that it is more clear. So indicating one electron, then we are going to have the one for chlorine here. So chlorine is going to maintain the electrons, the shells I mean, because it's only one, so we are going to maintain 3 shells. It is one electron that it is receiving for it to be stable, and since it is one electron that it is receiving, we are going to put a negative there to indicate that the number of electrons that this is gaining, or it has gained, it's 1. So from there we are going to write for chlorine. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically this sodium, after losing one electron, it is going to remain with 10 electrons. Then for chlorine we are going to have 1, 2, then here the second shell is going to have 8 as well. So 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay, wonderful. So what we have formed here is what we call the ionic bonding. So this is ionic bonding. Actually here we are supposed to use cross and dots. So since we have used cross here, we're supposed to use dots here to make it more wonderful. Yeah, to make it at least there's a difference to see. Yeah, like you've done here. So after losing one electron, then sodium is going to be stable. After gaining one electron, chlorine is going to be stable. So this type of bonding is what we call the ionic bonding. Equally here, it is going to be the same. When you look at magnesium, so magnesium has the atomic number of 12. Then when you look at oxygen has the atomic number of 8. So writing the configuration for magnesium will be 2 to the ratio 8 to the ratio 2. Then for oxygen, the electronic configuration will be 2 to the ratio 6. That means for oxygen, it needs to gain 2 electrons for it to be stable. And for magnesium, it needs to lose 2 electrons for it to be stable. Look at this. We have 2 here. We have 8 here. So it will be easy for this magnesium to lose 2 electrons for it to be stable. For this oxygen, it will be easy for it to gain 2 electrons for it to be stable. So once it gains 2 electrons from 6, it's going to have 8 electrons to make it more stable. So I'll leave it to you now to write the bonding between magnesium and oxygen. You show the reaction, the type of bond between magnesium and oxygen. You write it like this. You show the structures very well between magnesium and oxygen. So for me, I'm going to end here, and I'll be following the answers from you guys. So ensure that you answer very well. I can still add another examples. We can talk about any reaction. Even you can add any examples. You can talk about sodium, and we can talk about calcium. It is a metal. We can talk about many other metals and non-metals. Okay, so thank you so much for following this video, and if it's for the first time, don't forget to like, share, and subscribe to my YouTube channel, that is Sharp Tuition Center. Okay, so thank you so much, guys.